Hello, I'm going to show you the solutions to the review problems for normal distribution. So in the first problem, we have Patricio doing her internal assessment for math studies. She decides to show that the distribution of how many times people access their iPhones during class is a normal distribution. Okay, and she finds that it's a normal distribution with a mean of 12 and a standard deviation of 5. Draw that normal distribution, or sketch it. Okay, in the middle we have 12 because that's the mean. On either side of 12 we have 12 minus 5 is 7, 12 plus 5 is 17. Why 5? Because 5 is standard deviation. These lines are separated by a standard deviation. Okay, so another student guesses that the percent of students who access their iPhone less than 5 times per class would be at least 20%. Now Patricia is going to argue against that because she can already look at her distribution and use the 68, 95, 99 approximation to see that 20% is wrong. Now we're going to see how she does that. Okay, so let's just label her distribution, which has 12 in the middle, 7 to the left, and 17 to the right, with the numbers from the 68, 95, 99 approximation. So we have 34, 13.5, 2, and 0.5. Okay, so if this section is 34, what is this and this and this together? It's 16%. Okay, so we know that the number or the percentage of people who access 7 times or less is 16%. All right, now this other student is guessing that 5 or less times would be 20%. Can these both be true at the same time? Well, let's compare the pictures. We draw this section, which is like 5 to the left, and we're going to say it represents 20% of the area. And then we're going to look at the top one, and we can see that 7 or less is 16%. Now, can these both be true at the same time? This area be equal to 16% and this smaller area be equal to 20%? It can't, right? Because this area is actually smaller than this one. It can't be 20 and this one 16 at the same time. So if Patricia is right, then she knows that the other student is wrong. Okay, 1C. Use your GDC to figure out the correct percentage of students who access 5 times or less. Okay, so the guy was guessing that it was 20%. Let's find out the real number. Okay, now we just use the GDC to figure out what the area is with this lower boundary and this upper boundary. Well, the lower boundary, you say it's to the left. How far to the left? Well, normally when it's like all the way to the left, you use negative infinity, and that's what we're going to use here. Okay, so the name of the function is the normal CDF function, which we find by doing second distribution, and then we push number 2. And then it already fills in the first one correctly because we want negative infinity here. The first one's negative infinity. Lower is negative infinity. Upper is going to be 5. And the mean is going to be 12. And the sigma, the standard deviation, is going to be 5. Right? So the answer is 0.0808. I'm going to round it to 8 here because this 5 rounds it up, right? So the answer is 0.0808, which in percentage is 8.08%. Okay, number 2. Now I'm going to draw the normal distribution showing that 16% of the population have feet longer than 25 centimeters. We don't know what the mean is, so we're just not going to write that down. We know that 25 is going to be somewhere on this number line. We're going to put it here. And then 16% of the population goes here. We're going to color that in. Now, how do we know that 25 is on the right side and not on the left side? Well, we guessed that it's on the right side, and we can see that the 16% we colored in here corresponds to an area which makes sense, right? Because if we put it to the right side of the mean line, then we know it's going to be 16%. If we're on the left side, then we can see that it would be wrong, because if we tried to put the line here, 16% to the right of this, this is going to be like way more than 50%, right? So we can see that we're right in putting the 25 to the right side of the mean and not to the left side. So we drew our sketch correctly, even though we don't know the mean yet. Okay? Now we get one more piece of information, which is that the standard deviation is 40 millimeters. Now figure out the mean. Now we can do that because with the 68, 95, 99 approximation, we can figure out the percentages in between the standard deviation lines, and of course I carefully made this problem so that you would be able to figure out just using the approximation. So using the approximation, if you know that this part is 16%, then you know that the 25 is exactly on a standard deviation line. So let's draw the rest of the graph. 0.5, 2, 13.5, 34, 34, 13.52, and 0.5. And remember that 13.5 plus 2 plus 0.5 is actually 16%. So that's why this is such a special number, and 25 is right on the standard deviation line. Okay, what about the mean in this case? If we know that the standard deviation is 40 millimeters, can we figure out the mean? Yes, we can. Now, don't just take 40 and subtract it out of 25 and think you have the answer, because 25 is 25 centimeters. 40 is 40 millimeters. It's not centimeters. You have to change from millimeters to centimeters in order to be able to subtract that. Well, hopefully you'll remember that 10 millimeters is a centimeter. You can change 40 millimeters to centimeters by multiplying by this ratio, which is equivalent to 1 centimeter over 10 millimeters. Okay? 1 centimeter is equal to 10 millimeters, right? So you're going to divide 40 by 10, and you're going to get 4. So 40 millimeters is equal to 4 centimeters. Now you're going to take that 4 centimeters, and you're going to subtract it off of 25, and you're going to get the mean, which is 21 centimeters. Okay, so since I chose carefully this number to be on a standard deviation line, you can use the 68, 95, 99 approximation to figure out that the mean is actually 21. Okay, problem 3. The GPAs in 11th grade of the EAC have a mean of 2.5 and a standard deviation of 0.4. Draw a sketch of the normal distribution with these characteristics. 2.5 goes in the middle. 2.1 is 2.5 minus 4.4. And the standard deviation line above is 2.5 plus 0.4, 2.9. Okay? Now, if we want to give an award to the top 5 students of 42 total students, what would be the approximate minimum GPA to receive the award? Okay, let's first draw an area, sketch an area on the graph which is equivalent to these top 5 students. Well, first we need to convert it to a percentage, so I gave this hint. What is the percentage of 5 students out of 42? 5 divided by 42 is 0.119, 11.9%. Okay, so this area is 11.9%, and we're going to figure out what X GPA is. Okay, so I actually made a mistake here in the solution. Now the calculator, when it uses the inverse normal function, which you get by pressing number 3 here, it's asking for an area here, and then it asks for the mean and the standard deviation. Now, you're going to give it the area. Are you going to give it 11.9%? Well, the tricky thing is, it only asks for the area. It doesn't ask you where the area is. So the area here is on the right. But what if I had an area on the left? Or what if I had an area in the middle? How is the calculator going to know which area I'm giving it? Well, the calculator is always going to assume that whatever area you're giving it ranges from negative infinity to whatever number it's going to give you. So it's always going to assume that the area is on the left side and not on the right side. Now, in this case, unfortunately, we're on the right side, not the left side. How would we trick the calculator into thinking that it's doing the calculation for this left side, even though we only have the right side? Well, we find out what the area is for the white region instead of the blue region. Okay, we know the blue region. We know that the whole thing is 100%, so we can figure out the white region. Well, you can see the mistake I made here. I did 100 minus 11.9, and it gave me 98.1, which is wrong, right? It should be 88.1. Okay, so the area is going to be 88.1%. Now, when I put that in the calculator, I need to divide by 100, right? So it's 0.881 instead of 88.1. The mean is 2.5, and the standard deviation is 0.4. Okay. So this is going to give me 2.97. So actually, X is going to be 2.97. The minimum GPA to be a top 5 student is going to be 2.97. And here I have 3.33 because I used the wrong number here. If I use 0.881 instead, it's going to give me 2.97. Okay. Now we're going to relate box and whiskers plots to normal distribution. Now, I told you at the beginning of this unit that box and whiskers plots can represent any distribution, and normal distribution plots can only represent normal distributions which are very specific. Why are normal distributions specific? Because you can see their shape. They have a big lump in the middle, and they trail off on the left and right side, and they're symmetric, whereas box and whiskers aren't necessarily like that. But a box and whiskers plot can represent a normal distribution, and we're going to show that here. Now, remember what's special about a box and whiskers plot. A box and whiskers plot is special because 25% of the people are here, 25% of the people are here, 25% of the people are here, and 25% of the people are here. Now, what if we were going to do the same thing with a standard or with a normal distribution? We're going to put 25 here, 25 here, 25 here, and 25 here. Now, we can do that. It's just like, what is this number then? So if the mean is 2.5, what would be this line to make it so that this is 25%, this is 25, this is 25, or this is 25? Well, the calculator can tell us that with the inverse normal function. So we're going to go into the inverse normal function again. Oops. Inverse normal. Okay, and this time, instead of giving it 0.881, the area to the left of this critical line is 25%. So we're just going to put 0.25. And then the mean and the standard deviation are the same as before. So let's figure out what the GPA would be at this division. It's going to be 2.23. So 2.23 is the GPA which divides the lowest 25% from the rest of the school, or the rest of the 11th grade. What about this number? What would this number be? Okay, well, what we do here is we know that this part is 75%, this part is 25%. Now remember, the calculator is always expecting you to give it the area to the left of this line. So the left of this line would be 0.75, not 0.25. So we're going to go back to here. And we're going to use the exact same inverse normal, but instead of putting 0.25, we're going to put 0.75. The rest is the same. So the upper limit is going to be 2.7697. So if we round that to 3 significant figures, it's 2.77. So now we can relate this normal distribution to a box and whiskers. 2.5 is the mean or the median. It goes in the middle. In the problem, I give you the minimum and the maximum, which would be 4.0 and 1.0. So 4.0 would be the maximum. 1.0 would be the minimum. These blue numbers here are from here. So 2.23 would be the first quartile, or the lower quartile, which would be 25% up. And 2.77 would be the upper quartile, which is 75% up. So that's it. Good luck.